Hey folks, we're going to do section 3.0, which is called Introduction to Limits, Slope at a Point. So take some notes, use your paper here. This stuff you have to have your brain working for, so I hope you brought it today. So you're used to finding slope between 2 points. What I want you to look at now is, and consider, is finding the slope at one specific point, which is a crazy idea at first, but we use it all the time. It leads into the idea of instantaneous speed and instantaneous slope, which if you looked at your car speedometer on the way to school today, you would have been looking at an instantaneous rate of change, or a slope at a point. So I'm going to pause for a second and draw a quick diagram. Okay, this is our first example, and it's a big one, and you're going to do a lot of problems on this first time, just like this homework example, or notes example. So I graphed here the equation y equals x squared, which is a parabola you should know. It's like 0, 0, 1, 1, 2, 4, 3, 9. Basically, you can plug any x value in square it, and get the y value, right? So this is the point 3, 9 here. This is the point I care about down here because, I could ask to find the slope anywhere, but I want to know, what is the slope of that line right there, right now? If you look at it, doesn't it look like it's getting steeper and steeper and steeper as I go up? And less steep as I go down, but then it gets more and more steep in a negative fashion over here. So I want to know, what is the exact slope right at that point? So basically, our strategy is we want to find the slope of the curve at that single point. And the way we're going to do that the first time, before we learn all sorts of fancy tricks in here, is we're going to look at a slope above that point and the slope below that point and kind of squeeze in on our answer. And we're used to doing the squeeze thing when we did left and right side limits. But this is different because we're actually not talking about the y value that I'm squeezing in on, because I could tell what that is. It's right there. I want to know what the slope of this line is that I'm squeezing in on. So we're going to use a table to do that, okay? And you're going to recreate this table in your homework problems. Okay, so here's the table I want you to make, and this is on your homework problems too. Basically, the point I care about in the middle is going to be, well, for this problem, the point I care about is 2, 4. In your homework problems, it could be all sorts of points. I don't need anything else for these other ones. Okay, so what are my other columns? This is the x value. That's easy enough. This is the y value. And if you see a triangle here, that means change in. You've done that in chemistry class and physics class. We usually call it delta because it's the Greek symbol delta. So we're going to say delta x means change in x. Delta y means change in y. And guess what delta y over delta x is? Change in y over change in x, also known as rise over run, also known as slope. This is the column I care about, and we're going to pick some numbers above the 0.24 and numbers below the 0.24. And it's not just random numbers. I actually need to pick other points on this graph. So my first one, I'm going to pick one above it, like 3, 9. I'm going to put this way up here. Okay, we're going to squeeze in on it. But if I look at 3, 9, let me use a green colored pencil. I'm getting the average slope from here to here. Now this looks a little more steep than actually at that point. So my real answer should be less steep than this green line I showed. Well, what is my change in x from the original to the new one? It was a 2, now it's 3. My change in x went up 1. I'm going to put a plus 1. My y's were 4. It was a 4. And now it's a 9. It went up 5. Well, guess what? What's my change in y over change in x, also known as a slope of 5? That's how steep that green line is. It has a slope of 5. Okay, so let's do that with a point below. Let's go with this point right below it, 1, 1, right? So 1, 1 I'm going to draw this in orange. If I'm finding the slope between those two lines, this looks less steep than what actually is the slope at that single point. So the green one's a little more steep, the orange one's a little less steep. So the x value is 1, the y value is 1, because I'm picking a point on my graph. Okay, so from 2 to 1, what's the change in x? It went down 1. What's my change in y? It went from 4 down to 1. How about negative 3? What's my slope? Rise over run, which is a slope of 3. So my actual slope is somewhere between 5 and 3. And if you're betting, you might be like 4. What if it came out perfectly between the orange line and the green line sloped? I don't know. Let's squeeze in. We can get closer. How about what if I went to 2.5? Like, what's the point? 2.5 comma what? I don't know. Get your calculator out and square it. I think it's 6.25. I know it is. So that's the point here. 2.5 comma 6.25. If I looked at that slope, 6.25. Now we're getting closer, right? We're not the exact slope we need, but okay, so how much did x go up? It went up by 0.5. How much did y go up? 2.25. It was a 4, now it's 6.25. And if you put 2.25 over 0.5 and you divide it, you get a slope of 4.5. Okay? Similarly, we're going to go 1.5 over and up. If I square 1.5, I get 2.25. So now I'm looking at this line and we're squeezing in on slopes, right? I'm not finding y values, I'm finding slopes. So the slope of this line right here, it's getting really close to the slope of my actual dot. But if I plug in 1.5 for x, see how I'm squeezing in on this too? I have 2.25. What's my change in x? It went down a half. My change in y went down, I don't know, how much did that go down? Down 1.75 from there to there. Okay, and if I take negative 1.75 divided by negative 0.5, I'm going to get 3.5. Ooh, my bet's looking good. So my real slope at that point is somewhere between these two. But now let's get crazy. Let's get real close. What about just barely bigger than 2, like 2.1? Okay, if I go to 2.1, I am barely on the other side of this. Okay, it's a tiny little bit. It's almost the same slope. If you plug it in and square it, you get 4.41 for the y value. How much did the x change? It went up 0.1. How much did the y change? It went up 0.41. And that, you don't need a calculator, just move the decimal place. That has a slope of 4.1. And the last but not least, if I go just barely below this, 1.9, then I plug that in and you get 3.61 when you square it. So how much did it go down? Down 0.1. How much did this go down? Down 0.39. And you get a slope of 3.9. I think you can tell what we're squeezing in on. The slope at that specific point at the point 2 comma 4 is 4. Now that has nothing to do with the 4 there. It actually just has everything to do with the slope. And if you're ballparking it, it kind of looks like, if I looked at this slope of that line looks like, 4 is not a bad estimate. It's pretty steep. It's not like straight up and down where you'd expect a slope of 100. It's not horizontal where you expect like a slope of 0. So we squeezed in on our slope with this table. You're going to recreate that table a couple times in your homework. It's a little painful at first, but then you eventually get there. I'm going to show you a little different way in my other video.